given the graph to the right. Okay. What is the maximum area of the rectangle given that xy must lie on the line from 0, 2 to 3, 0? Okay. So, okay. So we want two equations. Our first equation is going to be for area. This should be pretty straightforward. X times y. We also know that the relation between x and y, we'll call that x, call that y, would be they have to land on this line. So to do that, we're going to get an equation for the line. So y minus y1 equals mx minus x1. So that's the general equation for how you find a line. Now m will be rise over run. So it'll be delta y over delta x. Which the rise here will be, it goes from 0, 2 to 0. So it'll be negative 2. And then the x goes from 0 to 3. So it'll be negative 2/3. And the point we'll probably use, let's say, we'll use 3, 0. So y minus 0 equals negative 2/3 x minus 3. So 3, 0. And then we'll distribute here. We have y equals negative 2/3 x plus 2/3 times 3, which is 2. It makes sense because the y-intercept is 2. So that seems to work. Okay. So now we have our two equations. 2, dos, de va. Okay. And so now we can plug this into this equation up here and then optimize everything in terms of x. So we use this equation and that equation. So we have a equals x times negative 2/3 x plus 2. Because we see this a equals xy. Ooh, a little bit too exuberant. Okay. Negative 2 over 3 still. But now we have x squared plus 2x. A derivative with respect to x is negative 4/3 x plus 2. We just took the derivative. So the 2 came down. And we were left with 1. We'll set that equal to 0. So we have negative... Alright, so we'll have 4/3 x equals 2. I just moved the negative 4/3 x to the other side and then swapped them around. So then we have 4x equals 6, x equals 6 over 4, which equals 3/2. Okay, so x equals 1.5. X equals 1.5. Therefore, y equals negative. I'll write this as 3/2. There we go. We'll use this equation here to find out what y is. Except I wrote it a little bit too far over. Move it here, turn it sideways. Yeah, I'm good with that. Negative. Don't want that though. Okay. So now y equals negative 2/3 times we know x is 3/2 plus 2. So then we have y equals 0. That doesn't feel right. No. 1. So this is equals negative 1 plus 2, which equals positive 1. So we have the point x equals 3/2, or x equals 3/2, y equals 1. We're supposed to find the area. So, this might have actually been drawn to scale. I feel like a chump now. Okay, so 3/2 times 1 is 1.5. Therefore, the area will be 1.5 units squared. 1.5 times 1, area. That was drawn to scale. Interesting. Okay, so backtrack. Given the area to the right, you have a rectangle that's basically the corner of this rectangle is stuck on a line. And so you have an equation for the rectangle, the area of the rectangle, x times y. And then you have an equation for the line, and you know that the two will be related. You solve one for one variable, plug that variable back into the other one. In this case, we used area. So we had area with respect to x. We then took the derivative with respect to x so that we could optimize it. Set the derivative equal to 0, took that point, plugged it back into our values, and that gave us our maximum area for a given constraint. Now, we could tell that it wasn't a minimum though, just because you can look at this and be like, okay, that's, be too thin. If it goes too much the other way, then you'd have too short, and it just wouldn't maximize the area. Like the most efficient shape for surface area with respect to area, well, it's a circle. But if you're, thinking more along pointy rectangular sides, the most efficient rectangle for volume to surface area will be a square. And so the more squarish we can make it, the better. And so that makes sense in why that would be the maximum and not the minimum. Because you go ahead and always have that doubt in your mind when you have critical points. You're like, all right, is this a maximum? Is this a minimum? In this case, it's like, okay, it's obviously going to be a maximum. Okay, give the graph right. All right, I think we got most of this one. Excellent. Thanks. See you on the next question.